A quadratic function models the height in feet of an object above the ground in terms of the time in seconds after the object is launched off an elevated surface. The model indicates the object as an initial height of 10 feet above the ground and reaches its maximum height of 1034 feet above the ground 8 seconds after being launched. Based on the model, what is the height in feet of the object above the ground 10 seconds after being launched? Okay, now let me draw an XY plane. Over here we have the y-axis and here we have the x-axis. And I take the time on x-axis in seconds, and I take the height of the object on y-axis in feet. Okay, let me take the value 10 on the y-axis over here. And the question says that the initial height of the object is 10 feet above the ground. So this is the initial height. So this is a position from where the object is launched. The object keeps going up and it has reached the maximum height of 1034 feet. So then we have the value 1034 feet on the y-axis over here. When the time is 8 seconds, then we have to take 8 on the x-axis over here. After reaching the maximum height over here, the object starts coming down. Okay, now, so the path of the object is a parabola with the vertex 8, 1034. Okay, here we know the vertex of the parabola, that is 8, 1034. So we can write the quadratic function in vertex form, which represents the path of the object. So the vertex form of a quadratic function is y equals to a times x negative h the whole square positive k. Here y equals to a times x, h is the x coordinate of the vertex, that is 8 seconds, x negative 8 the whole square, positive k is the y coordinate of the vertex, that is the height 1034. Okay, here the quadratic function is not complete because it contains an unknown constant a. To find the value of this constant, we need a point on the parabola. Let's consider this point. Actually, this is a y-intercept of the parabola, because at this point the parabola intersects y-axis. The y-intercept always the x-coordinate is 0 and the y-coordinate is 10. Now we can plug in this point into this quadratic function to get the value of a. Okay, let's plug in the x-coordinate 0 for x and the y-coordinate 10 for y. Then we have 10 equals to a times 0 negative 8 the whole square positive 1034. Okay, let me subtract 1034 from both sides of the equation. Then this positive and negative value will cancel out. When I simplify this one, I am getting negative 1024 equals to a times 0 negative 8 is just negative 8. When I square negative 8, it will become positive 64. Now we can divide both sides of the equation by 64. Then the 64 will cancel out. Okay, let me divide 1024 by 64. Then we get 16. That is the simplification of this one is negative 16. On the right side, we have a. Okay, here I got the value of a. Now, what we can do is we can plug in the value of a over here in this quadratic function. Then we have y equals to negative 16 times x negative 8 the whole square positive 1034. And our aim is to find the height of the object around 10 seconds after being launched. That is, we have to find the value of y, that is height of the object, when time is 10 seconds. That is the value of x is 10. So let's plug in 10 for x over here. Then we get y equals to negative 16 times 10 negative 8 the whole square positive 1034. Okay. Now let me do some simplification over here. So 10 negative 8 is 2. The value of 2 square is 4. 4 times negative 16 is negative 64 positive 1034. Okay, here when I combine this negative value and positive value, I am getting 970. That is when time 10 seconds, the height reached by the object is 970 feet. We find 970 in answer choice C. The correct answer choice for this question is C.